we are nearing the end of our unit here, and we're going to see how this goes. I didn't schedule any homework for today because this can be a lot. Today's a lot of vocabulary. So we are on 1.6, describing pairs of angles. It's got a lot of vocabulary here. And you can see this is a nice little graphic here of all the different vocabulary we're going to be talking about today. And really, we have complementary, supplementary, linear, and vertical angle pairs. These are the vocabulary words that are really, really big today. The nice thing is you guys have already started piecing together a lot of meaning from the problems that we've been doing. So this is going to be, I think, going to go really well today. So let's talk a little bit about, first of all, adjacent angles right here. Adjacent angles are two angles that are next to each other and share a common side. So I have maybe here is angle number 1. And then the side of number 1 shares here with angle number 2. So they have this common side. So adjacent means next to, okay? So they have a side in common. And of course they can be all kinds of different shapes. Here we might have adjacent angles, angle 1 and angle 2. Well, no. I hate when my pens run out of ink on me. Damn. Okay. All right. So here we have angle 1 and angle 2, and again, they have this side in common, and they are next door neighbors. So we have angle 1 and angle 2. They are also adjacent angles. So there are many, many examples of adjacent angles, but they just have one side in common. Is this, let's see, what about these? 1, 2, 3. Are angle 1 and angle 3 adjacent angles? No, not angle 1 and angle 3. Are 1 and 2 adjacent? Yeah. Are 2 and 3 adjacent? Yeah. Okay. So angle 1 and angle 3 are not adjacent. Okay. All right. So adjacent, next to. Good. I think you got it. So we also have what are called vertical angles, and I think about them as like, I don't know, like a pair of scissors. It's always good to have a little example. So imagine if my scissors had straight, like little handles here, but as you have a pair of scissors, these angles on either end are always open at the same rate. Imagine if this was actually a straight line. You can see the handle actually bends here a little bit. But if they were just straight, they have this like pivot point. And as they open and close, those angles that are opposite one another, they open and close at the same rate. Does that make sense to you? Okay, it's a bad example because these are not straight scissors. But I meant to make something and I forgot. Anyway, so these are called vertical angles. And so if you have straight lines, so for instance here, here and here, that's a bad picture. Let's see. Doesn't matter how you draw it, like that. Okay, let's do that. So here we have two intersecting lines. When I do that, I'm creating angle 1, angle 2, angle 3, and maybe angle 4 here. Two straight lines like that, and they intersect at this single point right here. Vertical angles are two angles across from each other on intersecting lines. They are always congruent. I have a lovely saying, vertical angles are congruent. And this is the phrase of the day. Vertical angles are congruent is something we want to learn. It is a theorem. It is a definition. Vertical angles are congruent. Always, always. So they are across from one another. So which angles do you think are congruent? Yeah, angle 4 and angle 2. So angle 4 is congruent to angle 2. What other angle is congruent? 1 and 3, absolutely. Are they all the same measure? No, angle 1 and angle 3 are also congruent. Angle 1 and angle 3, they might be 100 degrees. Angle 2 and angle 4 might be 80 degrees. They're not the same, all 4 of them, but they are pairs the same. All right? So we get some congruent angles. They're just across from each other. So vertical angles, maybe you can think about it like the V is vertical. You see the little V's? So these little opposing V's, maybe that's a good way to remember that those are vertical angles. You see the V there and the V there. Yeah? Okay. All right. Let's see. A linear pair. You know a lot about a linear pair. They are two angles that are adjacent and supplementary. They form a straight line, I think is really the key here. I guess you need to know what supplementary is. We'll have to talk about that as well. So first of all, they are two angles that they form a straight line. So for example, here I have a straight line. And these two, we have adjacent angles, so they must have a common side. So there we go. Here we have angle 1 and angle 2. What's important here is that they form a straight line right there. How many degrees are on that straight line? 180, right? We've talked about this before. So we know that from one side to the other side here, this is 180 degrees. That we've talked about that before. When you go 90 degrees, the other side must also be 90, right? And 90 and 90 is 180. Okay, so we've talked about that before. And so what this means, if we have a linear pair, so angle 1 and angle 2 form a line, so they are called a linear pair. So there's the word line in there. They form a line, straight line, and because it's a straight line, we know it has to have 180 degrees. So the measure of angle 1 plus the measure of angle 2 should equal 180 degrees. Okay? Anytime they form a linear pair, we know that they equal 180 degrees. Well, what does that mean? All right, so what is 180 degrees? 180 degrees is any two angles whose sum is 180 degrees. So not just a linear pair, but any two angles who have a sum of 180 degrees. So I could have a lovely little linear pair where one is 60 degrees. What would the other side have to be? 120, very good. So these two angles are supplementary because 120 plus 60 equals 180 degrees. So they are what we would call supplementary. But it also could be random angles. So if I have an angle here who is, let's go 80 degrees, and I have a random angle here who would have to be 100 degrees, then those two angles are also supplementary because 80 plus 100 equals 180 degrees. So supplementary is a word, and supplementary really just means, if you see that word, that you have two things that would add to equal 180 degrees. So any two things add together to equal 180. Supplementary and complementary is the last word we need to learn today. And these are complementary angles, are two angles whose sum is 90 degrees. And so, for example, here I have a nice little angle with a little box in the corner. What does that box mean? It's 90 degrees. So we have two little perpendicular lines here. And if I put in a nice little third side here, I created an angle 1 and an angle 2. So I have adjacent angles. And what is their sum? 90, yeah. The measure of angle 1 plus the measure of angle 2 has to equal 90 degrees for a lot of reasons, but the main reason here is that I told you that it was a right angle, and so if it's a right angle, it has to be 90 degrees. We can also just use the word complementary, knowing that complementary means they add to 90. And so any two angles could add to 90. All right, they don't have to be adjacent angles. All right, just like this picture, we could have two random angles that add to be 90 degrees. Okay, so adjacent are next two. Vertical angles have that little two intersecting lines, and they're opposite one another. Linear pair forms a line, and complementary and supplementary, 90 and 180, okay? It's alphabetical. Complementary, 90 is less than 180. C comes first in the alphabet, yeah? All right, it's the lower of the two. All right, supplementary is at the end of the alphabet, much bigger. All right, it has the much bigger sum, okay? So 90, 180, complementary, supplementary, alphabetical. Make sense to you? Good way to remember? Okay. All right, so we want to identify types of angles. Check all the relationships between just angles 1 and 2. All right, so looking at number 1 here, what kind of angles are 1 and 2? Vertical, yeah, they've got that little V shape going on. We got the V above and the V below, so that is definitely vertical. Are they adjacent? No. We don't know if they're complementary, supplementary, definitely not a linear pair. All right, number 2. This is a tricky one. Tell me about angles 1 and angle 2. Adjacent, they are definitely right next door neighbors to each other, so they are adjacent. How do you know that they're complementary?
One side has a right angle, so in a line always equals.
Okay, so we already know one side is 90 degrees, which means the other side must also be 90 degrees, and therefore 1 and 2 are also 90 degrees. Does that make sense to you? All right, so we can be multiple things, okay? Number 3, what are 1 and 2? Are they vertical? No, so if I put a number 3 here, now which ones are vertical? 2 and 3 are vertical. 1 and 2 are not vertical. Oh, so 1 and 2 form a nice straight line there. What does that make them? A linear pair, absolutely. So they do form a linear pair. Adjacent, very good. Yep, they are next door neighbors. They share a common side, and so they are adjacent. Very good. If they're a linear pair and they form a line, what do they add to? 180, which means they are also supplementary. Yeah, so they form that linear pair. They're going to add to 180 degrees. So those make 180 degrees right there on that linear pair. Okay? Number 4. Tell me about 1 and 2. What do we think? Adjacent. Are they complementary? No. We don't know. This is the one thing in geometry that we never assume. Just because this angle might look like a right angle, it might appear to be. The only way we would know it was a 90-degree angle is if there was a little box in there, or they told us they were perpendicular, but we never assume anything. So, very good. Number 5. This one's very tricky. Tell me about angle 1 and angle 2. Wow, interesting. Vertical. Yeah, absolutely, they're vertical.
Adjacent.
Are 1 and 2 adjacent?
Oh, wait, no.
No. But you guys said complementary, which impresses me because I had to get there. How did you figure that they're complementary? Okay, so we do have a little right angle here, which means on the other side here would also be a right angle. But how is, I mean, and I get that 2, these 2 angles would also make 90 degrees. But how did you get that 1 and 2 would add to be 90? This is very tricky. The little marks, the arc markies? Okay, tell me more about these arc marks that we've got going on. So, interesting. I'm going to put a number 3 here. Tell me about angle 1 and angle 3. They're the same. Okay, so angle 1 is congruent to angle 3. And how do we know that? The little arc marks there. So angle 1 and angle 3 are congruent. They are the same. Well, if they're the same, and I know that that's 90-degree angle right there, what must both of them be? 45, right? Because 45 and 45 is 90. Okay. So the measure of angle 1 and the measure of angle 3 are both 45 degrees. Okay. So now, if the angle 1 is 45 degrees and angle 3, is 45 degrees, we also know, tell me about angle 1 and 2. They are also congruent. Angle 1 is congruent to angle 2. Why?
Because they're vertical.
Vertical angles are congruent. That's a great, vertical angles are congruent. If they're vertical angles, they're always going to be congruent. This is a lovely little theorem we're going to talk more about, okay? All right, so angle 1 and 2 have to be congruent because they're vertical angles, okay? So now we know that angle 1 was 45 degrees. What's angle 2 got to be?
45.
Also 45 degrees. So the measure of angle 2 has to be 45 degrees then, because they're also equal. Hey, very, very good. And so then the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So therefore they are in fact complementary. Ladies and gentlemen, you just wrote your first proof. Good job. This is geometry. We have to think through everything and give a reason. So we're going to be starting proofs in the next unit, and this is how we think, all right? So how did we get to complementary? It's a big, long process, okay? But we'll have a reason for everything, and it is very unique, okay? I try not to dwell too much on it, but I think they're cool, but it takes a while to get there. It's not easy, all right? All right, let's look at number 6 here. Vertical, angle 1 and angle 2 are, I gave you the answer just now, vertical. Yeah, okay. Again, they have the V, opposing V's there. All right, and then, very good. How'd you figure supplementary? Uh-huh. Beautiful. That was like a perfect logical thought process. Very good. Absolutely. We had one right angle, which means all the other are also right angles. So they equal 90 degrees. And of course, they are vertical, so those are congruent as well. And because they both add to 180, they are going to be supplementary. Way to go. Beautiful. All right. So now that we have a good understanding of angle relationships, we're going to work through a few problems here. All right, directions. Find the missing measures in each figure. Keep the angle relationships in mind. Okay. Tell me about this X degree angle and the 112.
They're vertical, so that means that X would have to equal 112.
Very good. Vertical, I love how you said because vertical angles are congruent. Very good. X must equal 112 degrees because vertical angles are congruent. If you always say because vertical angles are congruent, you're going to do a great job at proofs, okay? I know this, X must be 112 because I know that there are vertical angles and vertical angles are congruent. That is beautiful. All right, so tell me about number 2. 22, you got 22, 1 to 68. So X plus 68 should equal what? 90 degrees. They're complementary, and so if we subtract 68, Clayton, you already said it. What was the answer? 22. Very good. So x must be 22 degrees. Beautiful. What kind of angles are here? Number 3. Adjacent. Also, what else? Ah, very good. A linear pair. They form a straight line. They are a linear pair. And so we know that they must add to be 180. So 124 plus x equals 180 degrees. And we get 56. So again, if we just subtract the 124, we would get the 56 degrees. All of her work here, she doesn't actually show the work. She just gives the answers because these are what we would consider easy. Okay? I will always typically write out the equation, but maybe just jump right to the answer, okay? Because I want you to see where it's coming from all the time. All right, number 4 here. What do we know first?
X and Z are congruent.
Oh, interesting. Hey, I like that. I'm going to go ahead and mark my picture then. I know that X and Z are congruent because they are vertical angles, and then Y and 43 must be congruent. So I know that Y must equal 43 right off the bat because we know vertical angles are congruent. Very good. All right, then how do we figure out X and Z?
Because 43 and Z have to equal 180 minus 43, and whatever that is because Z and X are equal, whatever you get to Z is also.
Good. So Z and 43, so Z plus 43 form a linear pair. So we know that they have to equal 180. Beautifully said. If I subtract 43, that means Z must equal 137, and that must be the same as Y. X. I already solved for Y. 137 as well, because they're congruent. 137. Excellent. Good job. Let's look at number 5.
We know Y and X are adjacent.
True.
And then
There's also complementary for
Got complements, yeah, So we know right here, Z and 72 have to equal 90. Okay, so Z plus 72 have to equal 90, which means Z has to equal 18. Very good. Okay, so I'm going to mark that in there. I like to write in my angle measures once I know them. All right, very good. What else can we do here? How do we find X?
we know that the line YX is 180.
Ah, so this line?
Yeah.
Linear pair here. We got a linear pair. So the X angle plus the 72 should equal 180. Very good. And again, if I then subtract 72, X would equal 108. All right, so X is 108 degrees.
Which would mean, we would just take, Y would have to also equal that 180 because of the, 180 that they sit on.
Okay, so you have another sort of linear pair right here, is what you're telling me.
Yeah.
Yeah?
Y would equal 72.
Okay. Yeah, so for a lot of reasons, in fact. So Y plus, we said that X was 108, would also have to equal 180. So again, Y would equal 72. Is there another reason that Y equals 72?
Yeah, the vertical.
Ah, yes. So what's very cool about geometry is that there are so many different ways to get the same answer. So not only could we get there just using linear pairs in all sorts of directions, but Y and 72 are vertical angles. We didn't see it quite at first, did we? Because there's a lot going on in the picture, right? Okay. So that's kind of interesting. And it makes geometry hard, but also really kind of neat how you have to sort of spin the paper sometimes to see it from a different perspective, okay? All right, cool. Angle 1 and angle 2 are vertical angles. What does that mean? They're congruent. So angle 1 is congruent to angle 2. And if the measure of angle 2 is 105, what's the measure of angle 1? 105. Measure of angle 1 must also equal 105 degrees because they have to be the same. Okay. A and B are complementary. What does complementary mean? Equals to 90. So the measure of angle A plus the measure of angle B has to equal 90 degrees. All right, and they tell me that the measure of angle A is 42. So I can replace that with a 42 plus the measure of angle B has to equal 90. So what's B going to be?
Yeah.
48. Sorry, very good. So yeah, if we subtract 42, then the measure of angle B would be 48. 48 plus 42 equals 90. I'm carrying that one. All right, awesome. All right, angle P and angle Q are supplementary. What's supplementary mean? They add up to 180. So, and we know that Q is 64, so the measure of angle P plus 64 degrees should equal 180. Can we just subtract 64?
Yeah, 116.
116, good. The measure of angle P equals 116, very good. Awesome. How are you doing with this? Is this okay? Yeah? Awesome. Let's skip down. Let's look at number 10. Oh, we have so much time. Okay. I think you guys are going to get a little worksheet to do. Yeah. I don't want to keep lecturing all this time. It's no fun. All right. Let's see. The measure of angle PQT, right there, is 3x plus 47 degrees. And the measure of angle SQR also right here, is 6x minus 25. Well, tell me about these two angles. They're vertical. Very good. What do we know about vertical angles? They are congruent. So what is the equation I get to write here? Excellent. 6x, very good. 3x plus 47 equals 6x minus 25. And then we can go ahead and use that to solve for x. So I'm going to go ahead and subtract 6x. And I'm going to subtract 47. Is that negative 72? A negative or positive 24? Positive 24, good. Divide by negative 3, we get a positive 24. And then we need to find the measure of angle SQR. How do we find SQR? Plug it in, plug it in. So 6 times 24 minus 25. You guys have calculators, Andy?
119.
119? Awesome. 119 degrees, and there is our answer we're looking for. Awesome. Yeah, you guys are just doing so good. I'm so impressed. Okay. Let's do another. All right. Again, marking up your pictures is a very good habit to get into. So it says if lines, it looks like line or line segment, I can't tell. AB is, what's this symbol? Perpendicular, perpendicular. What do we get if we have perpendicular lines? 90-degree angles, right angles. So CD, so there is a right angle here, which means there's a right angle on the other side as well. Very good. It says DCE, DCE is right here, so 7x plus 2 degrees and ECB is the little skinny angle here, is x plus 8. All right, find the measure of DCE. Okay. What kind of angles are the red and the blue angle here? What could we call them? What vocab words could we use? Complementary, and they equal to 90. They're also adjacent. So, all right, so 7x plus 2 plus the x plus 8 should equal 90 degrees. Beautiful. So it's all about how do you set up your equations is everything that's happening here. All right, so we've got 7x's plus 1x is 8x's. 2 plus 8 is 10. So that's set equal to 90. And then what should we do to solve? Good. So we have 8x equals 80, which means? X equals 10. Beautiful. And then we want the measure of angle DCE. So DCE is right here. So what do we need to do? Plug in the 10. Yeah. So 7 times 10 plus 2 is? Hey, I knew that one too. All right. Good. Beautiful. All right, let's do, I had through 15. K, N, M, N, M. Okay, we will do this one. All right, it says K, N, M. K, N, M is right here, and it is 8x minus 5 degrees. And MNJ is right here, and it's 4x minus 19. 4x minus 19. Okay. Tell me about that pink and red angle there, those two angles. Why do they have to equal 180? They are on a line, so they are a linear pair, so we know that they must equal 180 degrees. Beautiful. So 8x minus 5 plus the 4x minus 19 should equal 180 degrees. Beautiful. Do I need to solve from there, or are you good to go? You're good to go? Okay, let's just set up then, because I think we understand solving and plugging in if we need to. Yeah? Okay. Because they're on a linear pair. Maybe we'll write that in. Because, do you know that? How you abbreviate because? B/C? We're going to learn a lot of shorthand in this class. Okay, because they are a linear pair. All right, because they're a linear pair. Beautiful. All right, let's just do some more setups here. All right, the measure of angle DEG, that's right here, 5x minus 4. And the measure of angle GEF is 7x minus 8. Oh, that's here. GEF is 7x minus 8. You'll notice I'm giving it a different arc mark because I don't know what it is necessarily. All right, and then it also says DEH. DEH is 9y plus 5. Ooh, interesting. 9y plus 5 is here. Now, I did something very strategic here with my colors. Tell me about those pink angles. Quentin, what do you got?
You can't add y and x together.
Oh, we can't do that, can we? We can't put those together. Cash, what were you going to say?
That they're vertical to the red.
Okay, so DEG, oh wait, no, not DEG, just kidding. Because that would be GEF, there we go. So GEF and DEH are vertical angles, so we know they are going to be the same measure. But I can't just write 7x minus 8 is equal to 9y plus 5. I can't do that. Why? Yeah, I can't write an equation with x's and y's and solve just that. So I need to start somewhere else. So where else can I start here? D, E, G, and G, E, F, because, okay, that's true. They both have X's. That's a big hint. But why? What did they form? They form a linear pair, so they equal 180. So 5x minus 4 plus 7x minus 8 should equal 180 degrees because they are a linear pair. All right? So if you were to go ahead and solve, it turns out that x would equal 16 degrees. All right. So getting that set up, and then if you were to solve, we would get x equals 16. Now, we need to find the values of x and y. So if I know that x is 16, what should I do? Yeah, we can plug it in. So I'm definitely going to plug it into the pink here, G, E, F. All right. So then, so 7, let's see, I guess I'm going to write it out sort of here. Let's see, I'm going to write the measure of angle GEF is going to be 7 times 16 minus 8. What do we get for that? 104. 104, okay. So this is 104 degrees, it turns out, 104 degrees. So what's DEH? Also has to be 104 degrees because we know that they're vertical angles. So 9y plus 5 must equal 104 degrees. And that's going to allow us to do what? Solve for y. All right, so I'm going to subtract 5, and that is 99, which means y is going to equal 11. All right, so there's kind of a lot we had to go through to get there, but we did get there. All right, vocab on 14 and 15, super easy here. We're just going to set them up. R and S are complementary. What does that mean? They equal to 90 degrees. So 12x minus 3 plus 7x minus 2 should equal 90 degrees. That's it. R and S add to be 90 degrees. Questions on that one? No, and we would solve from there. All right, P and Q are supplementary. What does supplementary? 180. What's the equation we can write for this one? Excellent. All right. So supplementary means things add to be 180. Complementary means things add to equal 90. And so as long as you can set it up, you can solve all day and night. Okay. Do you guys have questions for me so far? Are you good? Got it? Okay, excellent. Oh, that was pretty long. Okay.